Hey guys, in today's video we're going to be working on something a little bit unusual. Christmas lights, guys. It's time for Christmas lights. It's the week of Thanksgiving here, and I've got these Philips sets which have this odd problem. All of the green and most of the blue LEDs have died, just out of the blue. These sets are several years old, and they were working fine last year. And now we've got this kind of oddity with this problem. In fact, going through all the sets I have, probably about 15 or maybe 20 sets, got a good 75 or 80 dead green LEDs and probably another good 30 or 35 or so blue ones and one lone red one that was dead. So it's probably the material that was used to make the particular colors involved, but I'm going to go through and show you how to repair these. So you don't have to buy new ones. You can't actually just buy a new bulb because they want you to buy a whole set, particularly with the number that we need. But it's not a big deal to swap these out. So let's get into it. Okay, this particular type of set from Philips, and this is a set that probably was, first out in, I want to say like 2008, maybe 2009, maybe a little earlier, not sure. But this is a type of set where at the end where you plug it in, and at the end where you can extend and do a new set, you'll see these two objects here that are in line. And these are current limiting resistors. And so the type of circuit this is one where rather than a rectifier, you're actually running one half of the AC sine wave through two different circuits. Now we can see that if we plug the set in and we take the end with the extension on it, and we just take, for example, this dead bulb out. And what we notice is half the set dies. Half the set keeps working. So it's just a 60 LED set with 30 on one resistor circuit and the other 30 on the other resistor circuit. So that's how it's wired. So now we can get an idea for what the overall voltage drop is on the two different halves of the set, as well as the whole set altogether. But what about actually replacing the LED? Well, let's go through what you would do to figure that out. So go ahead and remove one of these, and let's go figure out how to replace this one. Okay, let's take a look at this current limiting resistor first. So if we stick a little piece of wire into the end here so that we can make a circuit, I'm going to zoom in here just a little bit, and then we come up to the socket that we removed that one green LED from, and we come in and make a connection here. We'll find out that what we've got is a 2.1 kilo ohm resistor. Probably could round that up to 2.2 kilo ohm resistor. So we've got a 2.2K resistor for current limiting in both ends. As far as the LED itself, when we go take a look at that, most of these LEDs are going to have a package like this. It's kind of thin on this side, and then they're inserted into here. But if we go find the midpoint of the circuit, 30 LEDs in, and I'll show you there's actually a different kind of socket used there, and that's where the two halves come together. It's just something important to note because the particular two sockets at the middle have their own type of connection. So let's see where that lies. Here he is. I know I marked him with a little piece of blue tape before. So in the middle here, where the two pieces come together, we've got a different arrangement. So all of the LEDs before we get to this point just have one wire going in and one wire going out. And then the ones after this are the same way. One wire in and one wire out. But the two in the middle have three wires. Right? Two in on one side and one out on the other. And if we actually remove the connector, we can see compared to the one we were looking at before, they're different. They're much wider. Right? So that's just something to keep in mind. It's just this particular juncture. It's a larger socket to accommodate the extra wiring. And this is where the two halves, or the two 30 count parts of the circuit, divide up and connect. Right? So from this point of the red one, in this case, back is one side of the 30, and from the blue one to the plug is the other side of the 30. So we just need to make sure that in these two sockets, we always put that particular type of connector into this receptacle. So let's go ahead and keep looking at what's actually in this guy. It's very simple. So there's a couple of leads, and all that's in here is a standard LED. Spinning these leads back, guys. This little plastic light diffuser just comes out. Just give it a little wiggle and it'll come off like that. And then the LED itself comes out of the diffuser. And so when we look at the LED, we can see a couple of physical characteristics that help us determine what the replacement should be. So we can see the shape, right? It's a circular LED with a dome top. Those are two physical characteristics that we'll need in our search for replacement. We can see that it's tinted green, and that's an optional. You don't have to have it tinted green. It can be clear. And we can also see that it is on the clear side, but it is somewhat diffused. So you can have what's called a water clear LED, and you can have a diffused LED, and you can have a tinted color or no tinted color. These other two pieces we'll reuse when we put the new ones together. So physical characteristics, we also want to be able to measure the size of the LED, and on this particular one, it's about 3 millimeters, which is a T1 size. So it's a 3 millimeter LED, green tinted, round, dome top. Now we need to know a couple of electrical characteristics. We need to know the voltage, in particular what's known as the forward voltage. So to do that, we're going to have to hook up a little circuit to test it. So let's do that now. All right, guys, to test this out, we got a very simple circuit hooked up to our power supply. And we have our power supply initially set to come on at only 2 volts when we first plug it in. We've got our positive coming into a current limiting resistor here, 330 ohms. And then we've got our one working green LED, so we got to definitely protect this guy. This is the only one I have left that was working. The others are kind of dim and about to die. And we've got this with the positive or the anode connection and the negative connection on the cathode side plugged in, as you see, with black and red. And all we're going to do is we're going to power on the power supply, rather. And I'm going to see if I can get this where you guys can see both here. Can I get this with both? Hopefully you guys, yes. So we got this set to 2.0 volts, and what we're going to do is we're just going to slowly increase the voltage until the LED illuminates. 2.5 volts. You can see it's very, very faintly starting to glow at 2.7 volts. But we need to get it fully illuminated. So we come up here, 3.0. So 3.0, it's somewhat fully illuminated. Probably could go just one hair more. But I wouldn't want to go any further than that. So between 3.0 and 3.1 seems to be the forward voltage for this particular LED. So now let's see what a blue one would be. So I'm going to turn this back down to 2 volts. I'm going to take our green one out. And I'll pop a blue one in there. Just got to get the right anode-cathode orientation. Got our power back on so it doesn't illuminate at 2 volts. Starts to glow a little bit at 2.4. Looks very illuminated at 2.7. But very similarly, it reaches a level of brightness that I would think is as far as we want to go at about the same voltage, 3 to 3.1. Now what you'll find is that the yellow and the orange and the red LEDs are a much lower forward voltage. And I'll put those in the description of the video if you happen to be interested in those. My focus here is on the green and the blue. So now we know the forward voltage. We know the shape, the size. We know some optional characteristics. What else is left to order replacements? Well, we need to get an idea about the brightness. And the brightness is kind of subjective. What we're looking at here is probably probably on the order, and I'm just totally guessing by, experience here with a diffused tinted LED like this, we're probably looking at about 500 to 600 millicandelas, MCDs. And I don't know that we'd be able to find something that's exactly in that range, so we'd want to look for something north of that. So something around the neighborhood of 700 mini candelas up to 1 candela or 1,000 mini candelas. So let's see what we can find and come up with for our order. So guys, with this kind of current limiting resistor approach, there's actually a flicker to these because they're taking the straight alternating current and they're only using half the cycle. But most people can't see it. You probably can't see it in the video. But I'm going to show you that that's what's happening, because what we're going to do is we're going to switch to a slow motion part of the video and splice that in so that you can actually see these guys go off and on with the cycling of the alternating. So that kind of fade out that you saw there is exactly what's happening on each half of this circuit independently. All right, guys, so after all that, what ends up being the closest approximation is this Kingbyte brand WP710A 10LZ GCK type of LED. This gets us our correct green color. It's clear rather than tinted, so that is might be an issue in terms of being too bright. Its brightness ranges from 500 mini candelas to 1.1. So we really wanted something roughly in the 800 area, maybe 900 tops. So this is kind of close. It's probably as close as we're going to be able to get. And we take a look at some of the other attributes on this guy. His forward voltage specification, so if I can make this a little bit bigger for you guys. His forward voltage specification is typically 2.6, maximum of 3, minimum of 2.2. So we were looking around 3.0 to 3.1, and this is as close as I was able to locate on something that kind of fits what we're measuring for whatever was used originally by the factory. Obviously, we don't have a data sheet, so we're trying to reverse engineer what's going on here. But we do have an idea about the current limiting resistors at both ends of the circuit, and we do know how many bulbs are involved, and we can get a count of the different colors, and each of the different colors, it turns out, has a roughly different forward voltage average, but we think we can work all that out. So all that done, when we take a look at this particular guy that we are going to use as a replacement, and we plug him into our test circuit, and we turn the voltage on there, and we start turning this up, we can see he lights up right at 2.4, just like the others. And I'm going to kind of tilt this a little bit away because this guy, don't want to look directly at these when they're lighting up. And if I take it up to 3.0, we can see he's really a lot brighter than we would want. Even with the diffuser installed, it's going to be on the more bright side than we really want to have. So let's see if we can tone this guy down by giving him a diffused surface. And the way we're going to give him a diffused surface, just for experimentation purposes, we're just going to grab a piece of 400 grit sandpaper, and we're just going to sand down the clear epoxy on here and make it opaque. That's simple. Right? And I won't bore you guys with watching me go do that. I got another one here that I've already done. But after a little bit of sanding, you can see we've taken it from perfectly clear to somewhat opaque. And now if we try testing it again, it doesn't change our forward voltage amount. We still come on at 2.4, 2.5. But the lighting is more uniform, and when we bring it all the way up to 3, it's a little bit dimmer. So we keep sanding this a little bit. We're going to be able to get very close to what the original specification called for. And why is that important? Well, you don't necessarily want it to be like laser bright. It won't look right. It won't look normal when combined with the other bulbs in the set. And it doesn't take much time to do one of these by hand to figure out if that's going to solve the problem. And then for the number I've got, what I'll end up doing is just putting all these into like a tumbler, like a Harbor Freight tumbler that we'd normally use to polish a part and get rust off of it. You can just throw these guys in there and it will scuff up this clear epoxy and give them all this kind of diffused appearance. So I'm going to see if just a little bit more hand sanding can get this where I want. And if it does, then we've got a solution and we just need to mass manufacture it and take a look at the finished product. All right, guys, after a little bit of work with the P400 and powering this guy up, and we bring him up to full 3.0 volts, he looks pretty good. He's still a little bit on the brighter side, but he is good enough for what we're going to be wanting to use this for. If we were to close this down and we were to go switch back to our original LED, our one living example, put the light diffuser on there, power him up, bring him up to his forward voltage. Now he's on his way out dying, of course, so he's not the ideal candidate to be looking at this, but because, you know, even with this off, he's just barely going at this point. So I think we've got it close enough, judging by the brightness of the other colors. Let's get a couple in the set and see how they look. So when reassembling these guys, what you want to do is the end with the little latch is the anode end, or the positive end. You want to run the guy into right about there, just so he's peeking up. And then we want to bend these leads. Like so. And then we want to clip those leads. So they fit right into the little reserved area in the molding for them. And then we're going to reinstall the diffuser. And we have just replaced the LED in the bulb, and it's ready to install. And you can see this one's got a little bit, maybe I clipped it a little bit too high, but we'll find out when we plug it in. So I'm going to grab our set. Move our little test rig out of the way here. And then install it into, and you can see we definitely need to clip this one just a little bit more because it's sneaking out a little bit. So let me do that real quick. Right. Okay, bend this little retainer down so that it holds it into position. And then let's fire this up and see how she looks. Not bad. Right? About as bright as one of the blue ones, or one of the orange ones that's original. So that looks pretty good. So I'm going to go through and replace them all and see how it does on the overall voltage drop. All right, guys, we've got it all repaired and back in service, looking nice and pretty for the tree. And you can tell, can't even tell the difference, right? So take a look at these four here. Let's see if you can guess which ones are the original and which ones are not, right? Just very, very similar. Actually looking at here, 2 LEDs from the original set and 2 that we did the replacement on. And we got this very, very close type of alignment with the colors by going through this process, right? We started off with the water clear on the case of the blue one, and then we 400 grit sandpapered it down till we got a bit of a diffuse going on it. And then I also came through with a blue Sharpie. This wasn't for cosmetic reasons, and gave it a color there. Not necessarily, here's one of the originals here, right? Not to give it any kind of cosmetic appearance, but just once again to soften down the brightness to get it exactly where I wanted it. In fact, over here you can see how many of these I ended up going through here, right? So it's a shame that all of this, 100 or so LEDs is landfill, but at least none of this is going in the landfill. So we salvaged that. A couple other tips for you, right? If you get one of these that are really hard to remove, take your small wire cutters, right, and just grab it right near the base and just kind of wedge it up. And that's usually enough to work it off to where you can get it out. There you go. Some of these just get in there really, really tight. This one here I could tell was going to be a tight one, and that can help get these things separated for you. So I hope this video has helped you out, inspired you to do some corrections. I'll put some part numbers and stuff down in the description. I'll also put a good website that was an inspiration for me to go try and do this repair rather than throwing these in the bin. If you found this useful, guys, hit the like button. And as always, thanks for watching and Merry Christmas.